Today we are going to cover how to make this kind of particle effect in Houdini. Um, it's a pretty simple setup where it's mostly driven by pop advection by a volume we'll create. But I think it's a visually interesting effect. And a couple quick announcements. Just join me in my Discord if you want at the link below. And also, if you want, I'm going to start a newsletter that is aimed at mostly beginner 3D artists, people just getting into it, just because I really want to do my part to help encourage people to get into 3D, because I know it can be intimidating at first and maybe you don't know where to start. And I put together some kind of just beginner where to get started resources. So yeah, that's the only thing. Join me on Discord and sign up for my newsletter, or share it with someone who wants to get into 3D if you know someone. But yeah, without further ado, let's hop into Houdini and get started. So let's throw down a geo container. Let's rename this as pop advect. Change the color, and we'll dive inside and create a grid. Let's give this some resolution. And what we're going to do is we are going to scatter points and use them in a pop network. And we're going to advect those points with the volume we'll create. So in our pop network, let's set the source to points so that it's sourcing the points that we tell it to explicitly in our scatter node, and turn off the guide just because we don't really need that right now. And then we can adjust some of these birth settings later. The next thing we're going to do is set up our volume that we're going to advect the particles with, and we're going to do that with a 2D smoke solver that is part of NTlib, which is a toolkit that is available on GitHub. So you can Google that, and I can put the link in the description, and you can download those tools and install them. And here I can show you. How easy it makes it to get set up doing a 2D pyrosim, which we could set up manually, but it's just easy this way. They've set up the tool really easily to have access to the controls you need, and yeah, so we're just going to do that. And if you've never installed HDAs from someone else before, the way to do that is to create a folder for your HDAs and make it somewhere, and put all your stuff in there, and then edit your environment variable in your documents folder where your Houdini is. By default, it is in your documents, and then your environment variable, you'll edit that, and you'll add a Houdini OTL scan path. You can copy this, line of code and then add the path where your HDA folder is. And then it should pick up all the HDAs you put in that folder. So that's what I do. Yeah. So now that we have this, installed, the first point is for the point to source density. You can source multiple points. So we're going to source a scatter. We're going to scatter some more points. Okay, cool. So we have our grid and we've scattered some points. We're going to create a 2D smoke sim. And we need to probably tweak some of these settings so that we get a little bit more interesting motion to advect our particles. So we need to probably increase the swirl size, I think. Let's try tweaking that. Cool. Yeah, you see, we're already getting something cool and usable within just a couple minutes of, playing with some settings, which, I think is really just important when you're wanting to focus on figuring out art direction stuff quickly. So yeah, I think it's a great tool. The library overall is just really cool. So we can tweak these settings more, but let's get this fed into our pop sim. So we can see that we have our pop simulation, and if we press play, we're getting our points, but nothing's happening because there's no other forces at work. So we're going to add a pop advect by volume, and the source should be our second context geometry, which is our second input. And then we're going to update velocity and set the advection mode to trace. And then let's see what happens. Cool. So our velocity field is working and advecting the points, but you can see we kind of have some issues. It doesn't really look right because what we're using is a 2D volume. So when any of these points get away from that plane, that flat plane of having a position of 0 on the y or z axis or whatever this up and down axis, it will stop affecting them. So we need to, before we advect the points, we can add a pop vop and tell the points to always stay at 0. So we're going to do a vector to float, open up the different channels of the position vector x, y, and z. So we want to work on y, and then we also need to convert this back to a float to vector eventually. So and then this will go back to position. What we need is this one. We're going to multiply by a constant, and the constant is going to be 0 because we always want the y position to be 0 in this case, so that our 2D volume can continue having an effect. So let's see if that has fixed our problem, and you can see that it has. So we can see the result of our 2D pyrosim throughout this whole timeline. It's not just on the initial part, and then it pushes the points in weird directions, and then it stops working. So we can see that being visualized here. And the cool thing too is you don't need a ton of resolution on here. This doesn't need to be the highest res sim in the world, because we just kind of need the broad motion of it. And it's going to be advecting it. Here we can see here. So we have our density, and then we have the velocity fields. So it's going to be advected by the velocity field. And sweet. So that is working. The one thing we can see is that our points are getting births from the same points every frame, which that's not what we want. We want to kind of fill this up quickly with a bunch of points. So we're going to change the global seed every simulation frame. So now we should be getting frame or points in new places each time, and then we can do the same thing on this birth seed. Life expectancy, we want to put that to something like 10, just because we're not going to run this simulation for a crazy amount of time. And you can see we're getting a better distribution of points, and then we can turn off the max points per frame in both our scatter and our popnet, just because we want to have a lot of points. So yeah, let's just crank up the number in the constant birth rate and see if that helps us. All right, so that's going to help give us more definition to our particles as they move around. One issue, you can tell that we're going to run into is having space between our points in the simulation. So yeah, like I said, we could try a couple different things, like we could create a surface that we wanted the points to stick to, and run our sim and have a pop-vop in here that told these points to always stick to that surface, and that could help spread them out more. But the way that I set this up, we're not gonna do that. So basically, we're kind of gonna brute force the solution and just deal with it by having tons of points, so that we can't really tell that there's all these gaps in the in between the particles. So the next stage of this, getting this set up, is after the fact, we need an attribute VOP to, you can see in the example, the points are displaced, right? And they're displaced in a way that it makes sense visually because it's following the density attribute. So as the density attribute is, kind of the simulation, it looks like it's being pushed along by the density attribute. It's really being pushed along by the velocity, but as it's being, so these areas of high motion are also high density, is essentially what I'm saying. And so we are going to displace the particles by the density value. So what we first need is we need our density attribute, because right here we can see we have our attributes coming out of the pop network, but we do not have a density attribute anywhere. So we need to grab that from the volume, from the 2D volume we've created. So the points to apply the attribute to, and then the volumes to use. So we want not CD, but we want density. And then if we go in here, we can see we have a density attribute, and it is not a 3 float. It is a single float. So we have to change that to visualize it properly. And then we can see we have our density attribute in here, which is what we need for our next step, is to displace these particles by the density value. So same thing, we're just going to do what we did earlier. Vector to float, float to vector, and then we're going to address this y component of the position vector. And what we're going to do is we are going to add the density. So let's bind. We need to bring in this density attribute because it's not here in our geometry VOP standard options. So we need to bring that in with a bind. And now it is in here, and we can add it to the y component of the position vector. And you can see like it's obviously working. And you can, you can have it be however you want it to be. This is where, art direction and the look you're going for comes into play. But we want to probably have a control here, so we can have a multiply on this density and then promote this parameter by middle mouse clicking. And then when we go up here, we should have a scale factor that we can use. Cool. So that's essentially like the bare bones of the setup, and then where we can refine things a little bit more. So maybe let's play with our smoke solver settings a little bit. We can maybe add some amplitude, and let's maybe can increase the evaporation rate a little bit and maybe increase the turbulence. Disturbance will add smaller displacement to the simulation. So like the turbulence is kind of large scale. The disturbance can be a smaller scale breakup of those larger patterns. But let's revert to defaults. So we want to make sure we have a good range of density that's represented, because that's kind of going to give us the contrast of these peaks and valleys. Is seeing some areas with pretty high amplitude and then seeing some areas with pretty low amplitude. The cool thing about pops is that you can work with them pretty quickly too. So yeah. And what else? We can even we could fit this density value as well, so that it's not allowed to go above a certain point, even if we are multiplying it. Okay. Another thing that I did was in the scatter, I added a attribute noise so that we can have a color on here that we can use or not use in our shading after the fact. So I didn't use it because I wanted to use the density as the color attribute as well. But it's something that you can use if you want to have a different way of coloring the particles after the fact. But yeah, let's go back in here and let's add another 0 to this and see if we can get something. Something is not right. Okay, so I turned relax iterations off because they're an expensive operation. So, but we need a couple of them to make sure the points aren't just stacking on top of each other. Yeah, so that is something we need. And you can see how adding them helps keep the particles apart a little bit, which is, like we talked about earlier, that's kind of one of the issues we know we're going to have with this setup. Okay, so you can see how this is using our density field and advecting these particles. And essentially the next phase would be to set up your camera. Basically, I set up a camera that would also get rid of the points outside of the camera's frustum, which is essentially like the field of view of the camera, which you can do as an optimization step. Let's set this camera up for, let's switch these. It's like a social media aspect ratio. Whoops. And, somewhere where we get a good range of our particles. And then, so these are ultimately going to be rendered as particles. We're going to need to, we're going to probably need to play with the p-scale as well. So that's something that in this you can see there is a difference here between these, let's see, these dark areas where the density value is low, the particles are smaller, and where the density value is high, the particles are larger. So we're going to link the density value to the p-scale using an attribute wrangle. And the way we're going to do that is first, let's use at p-scale is equal to channel ramp, which is how we're going to tell it how to act across the density attribute. So we're just going to call this scale, and we're going to make this at using the density attribute. And then we click this button to create our scale, and we can't see anything. But let's copy to points. Make sure you pack an instance so your Houdini does not crash. And then make sure you keep the scale at 1 so you can get an accurate visualization of what the p-scale looks like. And then let's see what we've got so far. It still might be, still going to be pretty freaking slow because there's a ton of points. But so we can see, exactly what I'm talking about. So here the density is 0, the p-scale is 0. Here the density is 1, and the p-scale is 1. So we can remap that range to, whatever we want. So like, let's make the bottom value is not truly 0, and the top value is not as crazy huge. Let's maybe see what something like this looks like. So we have like a factor of 10, Oh, no, never mind. We don't at all. Highlight. Now this would be like a factor of 10 between the smallest particles on the low density values and the larger particles on the higher density values. And also let's, before we do that, let's randomize our p-scale as well. So not all the particles look exactly the same. I have a preset set up for random p-scale because it's something I do a million times a day. And so we have the p-scale attribute that we're randomizing, set it to a custom ramp, 1 dimension, and then we can use a ramp to, kind of dictate what the result is going to look like. So let's feed that in here. Again, super slow, but let's reduce the global scale, and then we can see we have some randomness here. Let's shift this over so we have fewer large particles. That's not what I want. Okay, something like that, and then let's shrink maybe the values a little bit. Okay, and then we can now run that through our little code we just created. So now there should be, but one thing we have to remember is this is going to set this equal to what we put here. So if we want it to multiply it by an existing value, we need to add the multiply symbol. And let's see, because we already did our scaling here, let's set our ramp back to the normal values. All right, so maybe set this to 0.2, and then let's scale this up a little bit. Okay. So you can see now these are clearly bigger, but then we have some randomness in here. But we probably need to also increase this as well. Let's see. We gotta play this. And then let's use a color here. Let's turn this off. And then we'll use a ramp from attribute. Our attribute's going to be density. And then let's grab some. Well, we can just leave this at black and white for now. And then let's throw a light in here. Just so we have something that will light up the scene. And then this is set to particles. Okay, so everything should be good. Let's create a material network and an RS material builder. Name that particles, apply that to the particles, and then bring in that attribute, the color attribute, which is the default, and then we can remap that to whatever colors we want. Feed that into the base color of this, and then let's grab a couple, different colors here. All right, start with something like that. And let's see what we've got here in the render view. My light is turned the wrong way. Okay, of course. Okay, cool. Okay, now we can kind of finally see kind of what we're talking about here. And so yeah, you can see how our kind of setup makes some visual sense, because everything is kind of following this same attribute, which is also kind of following the flow of the simulation itself. So I think that's why this looks, visually interesting, because, multiple attributes are being driven by the very thing that's driving the movement of the simulation. So, yeah, we can kind of continue refining this setup a little bit in whatever ways we want. We can use this attribute to drive like the CD, which is a black and white value. You could use that to drive the metalness so that these ones don't have it and these ones do, and remap that so it's not as apparent, but that it's still there. And then we're probably going to need to remap that p-scale attribute a little bit still, because it's a little bit jarring the way it is right now. And let's make this black, not completely black, so we can kind of see those colors a little bit better. And we're probably going to, we can pinch these values into as well using the ramp after the fact. Let's play with some of these colors. All right, something like that's starting to look pretty cool in terms of the colors we have there. And then we can hop back in our scene and let's go back here to our scatter. Let's see if we increase that to 500,000. And what do we have in here? Also 500,000. That should give us a good amount of particles, which I think is a good reason to start trying to optimize. So like the HDA that I use is called Easy Camera Clip, and so essentially like it's gonna take this input here and clip it to the default camera 1. So I think that's helpful, because then we're only simulating what we need, and that's what's going in here. And we can also do that after the fact to speed up the rendering as well. So let's just check out what we've got here. Got some nice swirling motion. All right. Then we'll go on down here. And yeah. All right. Well, yeah, let's just check what this looks like in our render view. So again, like we could apply another one of these here after the fact, further optimize kind of our render setup. And let's see what we got. We could also adjust this here if we want to do a high level kind of update. And let's see. These to be rougher. Yeah. Okay. So we're getting there for sure. We don't want to use that. Let's just select one of these and turn on some depth of field, because this is a small event. These little particles moving around. And yeah, just play with whatever colors we like here. But yeah, I mean, essentially that is everything. Besides tweaking everything to make it look exactly the way you want to, but that's ultimately just a matter of personal preference and just continuing to work things until you like the way they look. But yeah, that's essentially the basis of what I did. So yeah, I think my first thought was to do this by having particles flow or stick to a surface, but then I kind of came up with this other strategy, which the only challenge is, these particles don't stay super close to each other. But I think with enough particles, it's not visible, so it doesn't super matter. And yeah, that is it for this one. And if you want the project file, just go to my Patreon, or I might include it in my newsletter. So if you want some other cool stuff like that, sign up for my newsletter or whatever. But come join me in Discord too. And I'll look forward to seeing you around. All right. Catch you in the next one. Bye.